So we now have our Tacoma equity map, and so if we click in here, just one of these block groups, and this is our attribute tables, and we will notice that we have, let's say, renter. Let's look at owner occupied burden, the owner cost burden. These are percentages, so if you were just to multiply that, you would get 28.36%. The render cost burden, 32.5%, so forth. So these are rates already, and so when you make a map, choropleth map, you want to always map rates. So for example, well, average life expectancy is just a number. Households. So the number of households in these block group would be 96.9%. So these are rates, and to understand these, and then later on you're going to have to format these attribute table as well, so the pop-ups are more representative and clear understanding of what the data is. So let's now create a composite index. So if we go to analysis, then we can go to tools, and we want to go to analyze patterns, and we want to calculate composite index. So now we want to select what layer we want to use, and we want to use the Tacoma equity index because this is the layer that has all the data in it that we just looked at. And next thing we want to do is select the fields. So if you look back on the assignment, under the livability index variables, it tells you which to use. So let's select in here, and instead of scrolling through all these to find them, an easier way to do would be, for example, the first one is average life expectancy. So here's average life expectancy. Again, these are kind of truncated. You might have to go to the Excel metadata file to know what the full abbreviation is, but this would be average life expectancy. We'll talk about reversing direction and weighting. Right now, we will just leave the weighting all the same. For example, if life expectancy in terms of the livability was more important than the other variables, you would give it a higher weight. So if you assigned it a 2, it would be twice as important or weighted twice as much as the other variables. But in our case here, we're just going to leave everything as a 1 unless you can justify why you might want to change that. So the next thing we want to do is add another variable, and this one is going to be insurance rate. So here's insurance rate. Again, we'll leave it as it is. The next one is median home value. Median house would be median household income, so we want median home. So this is where we might want to reverse directions. So for example, average life expectancy, if we're trying to figure out the livability, how good it is to live there, you want to live probably in an area where the average life expectancy is high. So that is good. Also, median home value might not be good. That might be more of a negative because it would cost more to live in that area. So we want to reverse that. So areas where median home value are high, if we reverse that direction, where they're low, it'll be more equitable to live there. So we might reverse that direction. Another variable we want to use is owner cost burden. Owner cost burden. So here again, we want to reverse that because if the cost of owning a home is very high, that's not going to make the livability index very good. That's not going to be a very advantageous place to live. So we'll reverse that order. So where low would be better than high. Add another variable here, which would be renter cost burden. That just happens to show up there. Again, if the rent is very high, that is going to be not as good as if the rent was low. So we want to reverse that order. We'll add another variable and we'll put, oops, gotta type it in there. So this is actually just shows up as pedestrian, but that is pedestrian bicycle crashes. Again, if you're living in a neighborhood that has a lot of pedestrian bicycle crashes, livability there might not be so great. So you want to reverse that. So you want to find areas where pedestrian bicycle crashes are lower. That would be a better livability score. Again, we'll add another variable here. Oops, gotta type in there. So we want to look at Tacoma personal crime. Again, we want to reverse that. And we'll type in here Tacoma property crime. Again, we want to reverse that, right? If you have high crime, not so great a livability. The next thing we want to do is enter a minimum and maximum value. From the minimum is going to be a 0 and the max is going to be 100. And this just makes it easier for to interpret the data. So where 0 is going to be poor livability, 100 would be a very advantageous livability. Now we want to give it a unique name. We'll call it, since we're dealing with the index, and then at the end include your initials. So livability index. And I think we want to keep everything the same. You can also estimate the number of credits it's going to cost. Doesn't cost you since you're at BSU, but if you were to work for a company, you would have to buy credits. And so this will tell you how many credits it uses. So now we can run that and it's going to create a feature layer with livable index, and we'll run that. And so now we have our livability index. So if I go down to the legend, so areas in lighter are going to have lower scores of livability, and areas that are darker purple have higher livability index scores. So if we click in here, this will show you all. I just clicked in this block group. Average life expectancy is 81.8 years. And in the following video, I will go over what these outputs indicate.